Today's lesson is on Chapter 1, Lesson 5, on words, equations, tables, and graphs. So yesterday we started looking at relations. Now we're going to look a little bit more specific at what a function is. And what a function is a relation, but it's a specific kind of relation. Remember, a relation is any set of ordered pairs. A function is a relation in which each member of the domain, remember the x's, each member of the domain, so x, is paired with exactly one member of the range, which is our y values. All right, so remember, we don't really care if we see a repeat in our y values. That's okay if different domains, different x's, give us the same y. But what can't happen is in a function, we cannot have an x value of 5 and a y value of 2 and have another ordered pair where the x value is 5 and the y value is -2 or 7 or 1. That's not going to be a function. So the x value cannot be paired with two different members of the range. All right, now our function rule is just the operation that is performed on the domain or on the x to get the range. Get the range. All right, so again, whatever happens to those x's to get the y, that's our function rule. Then we have function tables, and all this is it is a table that lists the x coordinates. It also lists the rule and the y coordinates, or our range. So an example of a function table would be, for example, okay, here's my x's, here's the rule, and here's my y's. Well, let's say that our rule is 2x plus 3. So if x is 1, I plug it in, I do 2 times 1 plus 3, and I get 5. Or if x is -5, I plug in 2 times -5 plus 3, and I get -7. Sometimes our function tables, we just make a simple x and y table too, right? And if we have our function up here, y equals 2x plus 3, we just put 1, 5, -5, -7, right? But technically, a function table also includes this section right here that has our rule on it. But as we get more familiar with them, we won't be using that section too much. All right? The next thing we're going to talk about is ways to represent a function. So the first way we can represent our function is just in words. So I've already written an example here, so you want to make sure you get that in your notes. So our first example is that a navigation message from a satellite to a GPS in an airplane is sent once every 12 minutes. All right, so the plane's going, and in 12 minutes, they get a navigation message. Another 12 minutes, they get another navigation message. So the next thing we want to do is we want to write that then as an equation. So what I want to think about is, okay, well, let's see, in 1 minute, 2 minutes, 3 minutes, there's not going to be a message, right? But then every 12 minutes, they get a message. So let's say that we're going to make our variables be t equal time, and m is going to equal how many messages they get. So we want to create an equation that's going to show that. So what I'm going to have to do is I'm going to say, okay, well, what I'm going to do is I don't know how many messages they're getting, but I probably know how much time is going to pass. So I'm going to take the time, and what am I going to do with that? Let's say that 10 minutes passed. Well, there's no message. Let's make it even because it's going to be every 12 minutes. So what if 24 minutes pass? Well, I take that and I divide it by the 12, and that's what's going to give me the number of messages. So my equation would be this right here. m equals t over 12. So make sure you think about in your head some examples and make sure your equation makes sense. Okay, so now I have the words, I have an equation, take that and I can make a table out of it. So again, I'm going to take my x value, which is going to be the time, and I'm going to take that time, and what did we say we're going to do with it in our equation? Divide it by 12, and I'm going to be left with my messages, or the y values, right? So let's put some examples. What if I had 120 minutes? Well, 120 divided by 12, I'm going to get 10 messages. What if I was in the airplane for 180 minutes? 180 divided by 12 is going to give me 15 messages. What if I was in the plane for 300 minutes? I would do 300 divided by 12, and that would give me 25 messages. The next thing I'm going to do is I'm going to make a graph. Right now we're just going to be using our quadrant 1. All right, so we have our x and our y as only positives. That's what we're going to be looking at today. So when I make my graph on my x values, you notice that I have pretty big numbers here, right? So I don't really want to start counting by ones, or I'm going to have a lot of numbers on my graph. So I'm going to say, well, maybe I want to count by 50s, right? So I'm going to make 50, 100, 150, 200, 250, and 300. Okay, then I'm going to look at my y values, and I say, well, I go up to 25. Let's see, I bet I can count by 5s. 5, 10, 15, 20, 25, 30. So 5, 10, 15, 20, 25, 30. It's okay to have different increments on your x and your y values, or on your x and y axis. So x and y, it's okay to have different increments, but it's important that these all stay the same. 50, 100, 150, 200, 250, 300, and so on. So I'm going to plot my points. All right, I'm going to go over to 120 and up to 10. I'm going to go over to 180 and go up to 15. And then I'm going to go over here to 300 and go up to 25. All right, and now I have my points plotted on my graph as well. If I wanted to label my domain I would say is going to be 120, 180, and 300, and my range is 10, 15, and 25.